To dilate a figure means to change its size. So you're either increasing its size or decreasing its size. So there's two types of dilations. There's enlargements and reductions. A dilation is created by taking your scale factor and you're going to multiply the coordinates of your points by your scale factor. So we're using the variable r to represent scale factor, but you could really use whatever variable you want. But if you ever see r listed, that's your scale factor. So you're going to take your x and your y coordinate, and you're going to take x and multiply it by r, take the y coordinate and multiply it by r. So you're taking your x and your y coordinates, multiplying it by the scale factor, and that's going to dilate it. You are going to enlarge your figure if your scale factor, so r, if r is greater than 1, so 1.5, 5/4, 2, that would enlarge your figure. A reduction is when your scale factor is less than 1, so maybe 2/3, 0.5, etc. So we have triangle ABC with vertices A at -3, -2, B at 1, -1, and C at 2, 4. And we are going to dilate this triangle with a scale factor of 2. So that means I'm going to multiply all of my coordinates by 2. So A prime can be -3 times 2 is -6. -2 times 2 is -4. B prime, 1 times 2 is 2. -1 times 2 is -2. And C prime, 2 times 2 is 4. 4 times 2 is 8. So we took this pink triangle and enlarged it to get the orange triangle. So our scale factor was bigger than 2, or bigger than 1. I'm sorry, our scale factor was 2, bigger than 1. Since our scale factor was bigger than 1, it's an enlargement. So these dilations are smeared off the origin. It's kind of like everything's like expanding out or contracting in based off the origin. So from the center, kind of like getting bigger from there or smaller from there. This is an enlargement. Our next example, we're actually giving you the pre-image and the image. We're giving you the original figure, A, B, C, D, the blue one. That's the original one. We're giving you the new figure, A prime, B prime, C prime, D prime, the green figure. So remember, we put a tick mark on the points to indicate that we've transformed them. So the original won't have a tick mark. The new one will have a tick mark. So our original point A, it's kind of hard to tell, but this is the y-axis and this is the x-axis. So the original point A is at 2, 1. And A prime, after we dilated it, is at 3, 1.5. And so we're trying to figure out what is R? What is R? What's our scale factor that's going to get us from 2, 1 to 3, 1.5? So if you remember, we're taking our point x, y, and we are going to multiply the x coordinate by r and the y coordinate by r to get our new point. So I'm going to take this one coordinate at a time. X is going to become r times x. So x, my original point, is 2. My new point is 3. So 3 is equal to r times x. Well, we know x is 2, so it's 2 times r. We're taking 2, we're multiplying it by r to get 3. So we're going to divide by 2. So our scale factor is 3 over 2, which is 1.5. The other way you can think about this is you're going to take your x-coordinate, or you can the y-coordinate, you're going to multiply it by something. You're going to multiply it by r to get 3. We're taking 2, we're going to multiply it by r, and that should give us 3. And then divide by 2, and that's how I got r was 3/2. Another way you could do, you can just look at the y-coordinates. I'm going from 1 to 1.5. That means I'm multiplying by 1.5. So my scale factor is 1.5, 1.5, 3/2. 1.5, those are all fine. And since this is greater than 1, it's an enlargement. Which makes sense. My blue rectangle is most obviously smaller than my green rectangle. So I know that my scale factor has to be bigger than 1 because it's an